Let us look at question number 41 now, students. 1 mole of a monoatomic ideal gas undergoes the following operation. Okay. So a T versus V plot have been given to us. The examiner seems to be interested in the statement which is incorrect. So let's start with option number 1, students. Option number 1, it says delta S from C to A is positive. Okay. So if we talk about the path from C to A, students, we can clearly see that from the path C to A, the temperature increases as well as the volume increases. Okay. So if we talk about delta S value, students, it is given by NCVln T2 by T1 plus NRln V2 by V1. Okay. Since T2 and V2 are both greater than T1 and V1 respectively, students, so the delta S from path C to A will come out to be positive, students. If we talk about statement 2 now, heat is released in path B to C. Okay. So if we talk about the path B to C, students, in B to C we have isothermal conditions. Okay. So delta T is equal to 0. Okay. And if we talk about the gas, students, we can clearly see that the volume of the gas, it decreases from B to C. It must mean that the work has been done on the gas. Okay. So work has been done on the gas and the temperature is not changing. It must mean that the gas releases heat. So statement 2 is also correct, students. If we talk about the statement 3 now, pressure increases in path C to A, students. So if we talk about the path C to A, we can clearly see that the slope of the straight line CA is constant. The slope of the TV plot will be equal to P by NR, and since N and R are constant, students, the pressure will also be constant. So this is not a correct statement, students. If we talk about the fourth option now, heat is released in A to B. If we talk about A to B, students, we can clearly see that the volume remains constant. Okay, if the volume remains constant and the temperature it decreases, it must mean that the system has lost heat. Okay, so there is no work and the internal energy decreases, so it must mean that the system must have released heat to the surroundings. Okay, so this is also a correct statement, students. So out of these given statements, only the third statement is not correct, students, and for this question we have to mark the answer as 3. Let us look at the next question now. Question number 42. Consider the given processes occurring isothermally at temperature T1, T2 and T3 on 1 mole of an ideal gas. Okay. So process 1, it says volume of ideal gas is made 10 times at temperature T1 Kelvin. Process 2, it says pressure of ideal gas is reduced 5 times at temperature T2 Kelvin. And process 3 is the volume is made 2 times at temperature T3 Kelvin. If the change in entropy associated with each of these processes respectively are delta S1, delta S2 and delta S3, then, okay. So if we talk about the given processes, students, we can clearly see that in all of these the volumes are changing. Okay. So delta S is equal to N CV ln T2 by T1. So this term shall be equal to 0 as isothermal process is happening, students. So this will be 0 plus NR ln of V2 by V1. Okay. So it does not matter at which temperature you're carrying out the process. All that matters is the ratio of the volumes. Okay. So in the first option or in the first process, the volume is made 10 times. In the second process, the pressure is reduced 5 times. It means that the volume is made 5 times as the process is isothermal. If you talk about the process 3 now, volume is made 2 times. Okay. So we can clearly see that delta S1 will be more than delta S2 will be more than delta S3 as represented mathematically by the given equation. Okay. So students, for this question we have to mark the correct answer as option 2. Let us look at the next question now. Question number 43. So we've been given S8 crown in the gaseous form converting into 8S gaseous. The delta H for this reaction is P kilojoules. If we talk about the second reaction, we have phosphorus white converting into phosphorus atoms and the delta H is Q kilojoules. If the average bond dissociation enthalpy of SS and PP bonds are equal, then the value of P by Q is equal to. Students, if we talk about the crown sulfur, we can draw this structure. So there are 8 sulfur atoms. It has the shape of a crown. Okay. So we can clearly see that there are 8 SS bonds. If we talk about the second compound, we have phosphorus white. So we know the structure of white phosphorus as well, students. Okay. So this is the tetrahedral structure of white phosphorus, students, and we can clearly see that there are 6 PP bonds. Okay. So students, it is given to us that in the first reaction 8 SS bonds are broken, and in the second reaction 6 pp bonds are broken. It is further mentioned that the average bond dissociation enthalpy of phosphorus and sulfur bonds are equal. Okay, so if the delta H, which is given as p kilojoule, be equal to 8x, then this will be equal to 6x. Okay, so the examiner seems to be interested in the ratio of p by q. So the ratio of p by q shall come out to be equal to 8x by 6x, which on simplification will be equal to 4 by 3. Okay, so if you look at the options which are given to us students, we can clearly see that for this question we have to mark the correct answer as option 4. Let us look at the next question now. Question number 44. Upon addition of 20 grams of a solute to 200 ml of water, the solution formed has a volume of 240 ml. Which of the following is correct? Assumed density of water is 1 gram per ml. Okay, so students, it is mentioned to us that 20 gram of solute was added to 200 ml of water. Okay, so 200 ml of water is equivalent to 200 grams of water. And it's given to us that the final solution which was formed has a volume of 240 ml. Okay, upon mixing these, we get a solution whose volume is 240 ml. Okay, so we've been given some statements and the examiner seems to be interested in the correct statement. So option 1, it says density of solution is less than that of solvent. So this is the correct statement, students. The solvent had a density of 1 gram per ml, whereas if we talk about the solution has 220 grams in total. So there was 20 gram of solute and 200 gram of water. So there was a total of 220 grams present in 240 ml of solution. So students, the first statement is correct. If we talk about the second statement now, molarity of the solution is more than that of the molality. Okay, so if we talk about the molarity, students, there are 20 grams of solute. If we talk about the molar mass, let us assume it to be ms. Okay, so this many number of moles are present. Okay, so if we talk about the molarity, students, it will be equal to the number of moles divided by 240 into 1000. So this is the value of molarity, capital M. If we talk about the molality, students, small m, it will be equal to moles of solute, which was 20 by ms, upon 200. So the grams of solvent is 200, students, and this has to be converted into kgs. So we have to multiply a factor of 1000 again, students. So we can clearly see that the denominator in the expression of molarity is greater. So students, the value of molality shall be greater than that of molarity. Okay, so if we talk about the second option now, the second option is not correct, students. If we talk about the third option now, it is not possible to find the density of the solution. This is not correct, students. We can clearly see that the density came out to be 220 by 240. Okay, if we talk about the fourth statement now, it is possible to find the molarity and the molality without knowing the molar mass of the solute. This is also not correct, students. We can clearly see that the molar mass of the solute is present in this expression. So without knowing the molar mass of the solute, the exact value of molarity and molality cannot be found out, although we can compare them. So students, for this question, we have to mark the correct answer as option 1. Let us look at the next question now. Question number 45. The same amount of NaOH which was used to neutralize 98 gram of pure H2SO4 was added to H3PO4 sample weighing 70 grams. The resultant solution further required 3.65 grams of pure HCl for neutralization. We have to comment on the percentage purity of the H3PO4 sample. Okay, so students, let us first use the H2SO4 and NaOH neutralization data which is given to us, students. So there was 98 gram of pure H2SO4. Of H plus. So to neutralize 2 moles of H plus, we are going to require 2 moles of OH minus. It must mean that 2 moles of NaOH had been taken. So now students, in the second neutralization, it is mentioned to us that the NaOH was added to 70 gram of H3PO4 and then the resultant solution further required 3.65 gram of pure HCl. So if we talk about this HCl, students, it has a molar mass equal to 36.5. So number of moles of HCl, it shall be equal to 0.1. So we can now talk about the equivalence. So we have equivalence or the gram equivalence of acid equal to base. So the gram equivalent of base is given to us, students. It is equal to 2. So 2 into 1. Now if we talk about the acid, students, we have 0.1 moles of HCl. So these many gram equivalents will be present of HCl, plus we're going to have the gram equivalents of H3PO4. So we can clearly see that the gram equivalent of H3PO4 will come out to be equal to 1.9. So the moles of H3PO4 is equal to 1.9 upon 3, as complete neutralization is going to happen. Okay, all the 3 abstractable protons will be extracted. Okay, so these many moles of H3PO4 are present, students. So if we talk about the percentage purity now, the percentage purity will be given by 1.9 by 3 into 98 divided by 70 into 100. So if we talk about this value, students, it comes out to be approximately equal to 88.67. So if you look at the options which are given to us, students, we can clearly see that for this question we have to mark the correct answer as option 3. Let us look at the next question now, students.